If you want to find the current in each of the ammeter, right, so perhaps it's easier if you try to imagine how the current flows, then you redraw the circuit. So the current will come out from the positive here, and then it will split. Can you see? 1, 2, and 3. So there are 3 parallel circuits here. So when we want to redraw, we can redraw it like this. So from the positive, it goes out to your A2, then it splits to 3. The first one, it will pass through A1. Now, when it passes through A1, it will pass through 2 resistors, right now? Alright, and then it passes through A3, which is another parallel circuit. This time it passed through 1 resistor. And then finally, it passed through A4, where it passed through 3 resistors. Alright, then you join back together, and then you get the circuit. So you can actually redraw it this way. And they did tell you that the current in A1 is how much? Is 0.6 ampere. So here is 0.6 ampere. So because they are all in parallel, right, what you can say therefore is that the PD across here must be equals to this, must be equals to this, must be equals to this. Do you understand? So therefore, what is the PD across this? Now you don't know what is the resistance, you don't have to put fake values. We can just use as each one as R. So what's the total resistance here? 2R, right now. So we can write as 0.6 times 2R, which is the PD across here, must be equals to this PD, right now. So shall we call this current I3, because using A3, and this current is I4. So 0.6 times 2R, which is the PD across here, must be equals to this PD, must be equals to this PD as well. So we should be equals to I3 times R. So you notice you can cancel this, and your I3 will be 1.2 amperes. And you can also do the same at working for the bottom one. So you can use 0.6 times 2R again, but this time is equals to this PD. So which is I4 times 3R. So the R can cancel. So your I4 will be equals to 0.4. So in other words, if I3, you already know I3 is 1.2 and I4 is 0.4. So what is A2, which is this current here, I2? So it will be a total of this plus this plus this. So 0.6 plus 1.2, which is 1.8, 1.8 plus 0.4, which is 2.2. So the answer is donkey. If you want to find the total resistance between P and Q, so the technique is to imagine the current comes in at P and comes out at Q. So how will it split, right? First, it will come in at P. Now, can you see that all 3 are possible paths? So it split to 3. So when it splits to 3, you can draw the 16, the 16, and the 8. Understand? And then after that, the 16 here will continue with another 8 and 8 in series. So you can draw 8 and 8 in series. Alright? And the 16 at the middle here will just go out. And the next one, 8, will pass through 8 and 16. So you pass through 8 and 16. So when you redraw, you will get this. Okay? So it's very easy now, because you see 16 plus 8 is 32. So 32, 8 and 8 and 16 also 32. So 32 and 32 in parallel give you 16. Then 16 in parallel with 16 gives you 8. So the answer straight away is 8.